When someone claimed that Salvador Dali was her father, they had to dig him up. But what most impressed people was his mustache. It was still perfect. And that's because his mustache is made of protein, the protein keratin. There's quite a story here about proteins, so stick with me. So proteins carry out the functions within you. Your DNA is your hereditary information, but the proteins are made of these amino acid polymers. Each of these little spheres is an atom. And polymers are long, long structures that are put together in various shapes. Collagen is one of the proteins that's really critical in your structures. This is an example of silk. This is silk. So silk, we depict in a different way. We show it as the strands in the background because we want to know a little bit about the structure. We can't see proteins, so we have to find different ways to look at them to help us understand what they can do and why they're stable. All right. So this is hemoglobin. Probably everybody already knew that, right? And you can see the little heme groups in here. Maybe you didn't know that. It's a tetramer. This other protein is the delicious enzyme invertase. I say it's delicious because that's the enzyme that makes the soft centers in those chocolate candies. And I've colored that one. Each amino acid is a different color. This is a very stable protein. This is avidin right here. Avidin binds the vitamin biotin. If you eat raw eggs, they bind up the biotin. You have a nutritional deficiency. The other one there is keratin. And because it's curly like that, like a phone cord, you can stretch it. You can stretch wet hair. And you can't quite stretch silk the same way. Now, where do you get your protein? Those of you who have been paying attention know we don't have a food pyramid anymore. We have a My Plate. And the My Plate shows you where you can eat your protein, from vegetable to animal sources. Some people take powders, like glutamine powder. Glutamine is actually an amino acid. But other powders come from eggs or whey. I used to have my own flock of chickens, and this was some of their eggs, so I'm showing off for you. Now you'll notice that one egg in the middle is gigantic, because sometimes chickens put 2 yolks in the tube that goes out and becomes an egg. The color of the eggs is related to their ear color, by the way. Nothing to do with how good the eggs are. But eggs are a great source of nutrition. They have proteins and carbohydrate and vitamins. And the vitamin that I'm most excited about is vitamin B2. Vitamin B2, riboflavin, is the vitamin that you actually see after you eat a healthy meal. Your urine is yellow. You might not have looked, now you will, okay? So vitamin B2 is necessary for all kinds of things. We have information about it because we have a flock of mutant hens, and because they're missing a protein, no riboflavin goes into their egg white. Next time you look at your raw eggs, you'll notice a regular egg is slightly yellow. Our mutants don't have riboflavin, and they die about the 13th day of their development. And so we study these. In humans, the riboflavin deficiency would be red eyes, scabby lips and tissues and tongues. Some of us would have scrotal dermatitis. Others might have something different. But riboflavin deficiency is manifested in many ways. In the United States, we don't see it a lot. So nobody worried about it too much. Now you're probably wondering, how do these chickens, how do they grow and develop? How do we keep this flock going? We actually inject the riboflavin into them. Riboflavin's a pretty cheap vitamin. So we take the fertilized eggs, we inject it, the adults grow. After that, they can just eat all the riboflavin that they need for their healthy development. So the problem with our mutants is this protein, and I've shown it in several different ways. Showing you the amino acids, showing you the riboflavin in different ways, showing you that it's stable because it has these bonds between the strands, very much like your hair strands have, why some of you have curly hair and some of you don't. So we have different ways to study this protein and see if it's stable. Now, a riboflavin deficiency in a chick might manifest as a crossed beak, like that. If you have a vitamin D deficiency, which is very much in the news lately, you develop rickets. So we are really interested in finding out how many people have a riboflavin deficiency. Now, this is a map of iron deficiency, and you can see that in some countries it's quite terrible, especially in women, pregnant women, and children. We don't have a map for riboflavin because we don't have a test for riboflavin. There's no way to easily check if riboflavin is deficient in these populations. So what we wanted to do was develop an assay. So how do you test an assay? Or how do you develop an assay? A biomarker is what we want to measure. We want to measure flavins. So to measure them, you take a sample, some kind of a detecting molecule, and you get a signal. The signal might be radioactive, it might be a color, or we even use the enzyme from fireflies and make the resulting product glow so we can see how much is actually there. That's how you develop an assay. So we take maybe a sample like that, our protein, which binds riboflavin, a special molecule that we're trying to design, an indicator, and then we do some math, okay? And then we know how much riboflavin is there. Our research right now is making this special marker. Our assay must be cheap, easy to use, accurate, something easy to test like urine, and it must possess a long shelf life. Now, we know that the other components are very stable, but we don't know if our protein is stable enough, so we have to check it. There are lots of ways we check proteins. I'm going to show you one of the ways that we check proteins. We run our proteins and then we color them on something called a gel. This is new protein. You can see that it's kind of between bigger and smaller. If the protein was not stable, it would degrade and become very small. Because I'm a pack rat, I've been carrying samples of protein around with me for 30 years. From my Delaware days to my New Jersey days. So I can actually see how stable it is. This is the riboflavin itself. I just wanted to show you how pretty it is. It's a beautiful little molecule. It's very tiny. You need the protein to get it to where it goes in you. That's why the proteins are so important in you, okay? Now this is the end. It actually takes a whole group of people to do this work. Chickens don't have mustaches, but they do have feathers. You know that the bottom end, the butt end of a chicken is very soft. Those proteins are made of keratin, just like rhino horns in your hair and your mustaches. I want to thank my colleagues, Dr. Smith, Marinchin. Our chickens are kept at Michigan State, and a lot of students have helped with this work. Thank you.